Chrysler Corporation's computer-studied 3-speed fully synchronized manual transmission is new for 1975. In less than 15 minutes, you will see how all the parts fit together. You will see how power from the engine flows through the gears. And of course, you will get many helpful service and overhaul tips. Now, this computer is signing off. The training session is turned over to you. Are you ready?
Here's the new A390 manual transmission. Here are the gears. By turning the input shaft, we can follow power flow through the transmission. Shift the first reverse synchronizer sleeve forward. This locks first gear to the output shaft. Power from the engine turns the input shaft, the counter shaft gear, and of course, first gear, which is now mechanically connected to the output shaft. Although the second gear is in mesh with its corresponding countershaft gear, it is not mechanically connected to the output shaft, so it just goes along for a free ride. Remember, too, there is no mechanical connection between the input shaft and the output shaft in first, second, and reverse. Before the transmission can be shifted into second, the first reverse sleeve has to be moved into neutral. Then, by moving the 2-3 synchronizer sleeve toward the rear, the second gear locks to the output shaft. Power from the engine turns the input shaft, the counter shaft gear, and the second gear, which is now mechanically connected to the output shaft. In second, the first gear remains in mesh with its counter shaft gear. However, since it is not mechanically connected to the output shaft, it is free to rotate. Okay, let's shift the transmission into third, or direct drive. Moving the 2-3 synchronizer sleeve forward locks the input shaft to the output shaft. Power flow from the engine now goes directly through the shafts, bypassing all gears. The first and second gears rotate with the counter shaft, but do not transmit any power since they are not mechanically connected to the output shaft. Now, with the transmission in neutral, let's shift into reverse. This brings in another set of gears in order to change the direction of rotation of the output shaft. Power flows through the input shaft to the counter shaft gear, the reverse idler gear, and then to the reverse gear, which is mechanically connected to the output shaft. Next, let's put all the gears into the case and go through major steps in overhaul. After getting the two housings and cover off, drive out the roll pin that locks the counter shaft to the case. Detent spring and plug are next. A few light taps on the shaft will pop the expansion plug out of the case. Now the shaft can be removed easily since it's not a press fit. Hold it. Don't push the shaft out the front of the case. Sharp edges near the roll pin hole may scratch the roller bearings. Use the arbor to take it out from the rear. Makes sense, right? Let the counter gear drop to the bottom of the case. This gives the input shaft some room to move back and forth and up and down so that the bearing can be walked out. Before you separate the bearing from the case, tip the case forward. This keeps the roller bearings from dropping out of position. There's no big problem getting the shift forks and shift rails out. Once the first reverse fork set screw is removed, the shift rail can be pushed out the rear. The shift rail interlock plug is next. Then the 2-3 shift rail set screw. Hold it. You'll break the casting that way. Here's a simple way. Pick up the wide blade screwdriver. That's right. Place the blade in the V section of the shift rail and bump it so that the V turns 1/4 turn. The shift rail can now be removed easily. Nothing to it. Get the detent plug and spring out, and then you can see why the rail had to be turned. That's right. The spring-loaded detent plug stops movement of the 2-3 shift rail. Turning the rail places a smooth section against the detent plug, and out it slides. You can't get the first reverse shift fork out while the rear bearing is still in the case. Tap the output shaft until the bearing separates from the case bore. That's it. Now, the shift forks are easily removed. But to get the output shaft out of the case, remove the small snap ring. The puller plate goes over the large snap ring, a few turns, and off comes the bearing. Out comes the shaft through the top of the case. Now lift out both the reverse idler gear and counter gear. Too bad you tipped the gear, spilling the arbor and roller bearings. Let's do that again. That's better. These thrust washers are for the counter gear and reverse idler gear. Those with a larger bore are for the counter shaft. Now for parts inspection. The synchronizer stop rings take a real beating even during normal shifting. Inner surfaces must have definite thread-like grooves. If they're worn smooth, new ones are needed. Small teeth on the stop rings must also be well defined. Battered or rounded teeth call for new stop rings. Clutching teeth on the input shaft and the first and second gear must also appear free of damage. After washing in clean solvent, ball bearings can be checked by rotating slowly. Synchronizers should not be taken apart unless absolutely necessary. Splines and struts can be inspected by moving the sleeve. Synchronizer assemblies are serviced only as a complete unit. If they must be taken apart, mark the hub and the sleeve to ensure identical reassembly. All roller bearings should be smooth and must not show signs of pitting or galling. Now for some assembly tips that will make your job easier. New O-ring seals here are cheap insurance. Coat them with transmission fluid before installing. End play checks are important. Install the 2 thrust washers for the counter gear. Hold it, you're using the wrong washers. The counter shaft takes the ones with a larger inner diameter, remember? Coat the flat surfaces on the tab sides with a film of grease. Tabs go against slots in the case surfaces. The front thrust washer is installed with the tab up. The rear one with the tab pointing towards the side of the case. That's right. With the counter gear properly installed, check end play. Specifications are in the reference book. If okay, push the shaft out with the arbor and lower the counter gear to the bottom of the case. The reverse idler gear must also be checked for end play. By the way, did you install the 2 thrust washers with the tabs facing up? Good. Now, to get the rear bearing on. Hold it. That could cause a lot of parts damage or crack the case. Here's a simple way. Tip the case over. Get that small block of wood and place it under the output shaft. That's it. Now the bearing can be easily tapped onto the shaft. Remember the snap ring. Shift forks are next. Then tap the bearing into the case bore. A detent plug and spring go into the detent bore. Hold it, use the short spring here. Insert the 2-3 shift rail. It's the shorter of the two. The detent plug must be pushed downward against spring pressure before the shift rail will enter. After the shift fork set screw is installed, tap a new expansion plug into position. The interlock plug is next. Then the first reverse shift rail. It won't go? You must shift the 2-3 shift rail into neutral position. Remember, the interlock prevents the transmission from shifting into 2 gears at the same time. Tighten the set screw securely. After the roller bearings are all in place in the input shaft bore, set the synchronizer stop ring into position and tap the bearing into the case bore. To align the counter gear shaft bore with the case holes, tip the transmission over so that the shift levers and the top edge of the case rest against the bench. Once the counter shaft bore and the thrust washers are aligned, push the shaft in from the rear. Hold it. Don't forget to align the roll pin hole with the hole in case. A drift punch with a shoulder at the end holds the roll pin from dropping inside the case. After the expansion plug is tapped flush or below the case surface, attach the extension housing and front retainer using a new seal. Hold it. Make sure the oil return slot is at the bottom so fluid will drain back into the case. Use a good quality sealing compound on all bolts. And, of course, new gaskets. Put the detent plug and spring into position and pour lubricant over the gear train. Try it out in all gears. Does it shift okay? Once the cover is on, the job is buttoned up, ready to install. Don't forget, all these details are in your reference book.